Welcome to this series of sessions on data engineering and model deployment. Let us first understand what is the objective of data engineering in the whole gamut of machine learning. So in most of the machine learning courses, you would have studied certain activities that you typically do when you try to build a machine learning model. What are those activities? Typically, you have some data and you would need to pre-process the data. For example, the data have some missing values. You may have to treat those missing values. The data may have some multi-collinearity. You may have to treat that. You may want to do some exploratory data analysis before you actually try to build the model so that you understand what reprocessing you should do. For example, you may draw a box plot to find out the outliers and treat the outliers accordingly, or you may have a correlation matrix to find out the multi-collinearity. You may also want to figure out certain fields that have very unique values for different records, which we call as high cardinality fields, and you may want to remove them. So these are various types of pre-processing that you need to do on the data before the data is ready for training in a particular model. So after you do that, depending on the type of machine learning model that you are working on, you may want to split the data into a train and test, especially if it is a supervisory learning technique, and you may want to train the model and then you may want to test whether the model is a proper fit, especially if you have to trade off the bias and the variance. You already have studied all of these things in a typical machine learning course, so I'm not getting into these aspects in this particular series of videos. Now, most of the data science courses are focused on these three components. But in reality, while these three components are extremely important and they're kind of the heart of the entire data science project that you may embark upon, in reality, it actually consists of probably 10 to 20% of the real work. Because this assumes two things. First is it assumes that the data which you are pre-processing and feeding to train a model, the data is ready for pre-processing and training. Now, while it may seem obvious, in reality, that is not the case. Why that is not the case? It is because the data that comes in organizations can be of various types. Today, the data is not one type. Originally, when most organizations started computerization, the data was only the transactional data. That means sales data, purchase data, accounting data, etc. But over a period of time, as computing power improved and as new technologies came in, this is not the only data that organizations are now using for building different models. What are the different types of other data? You have data like digital media data. That means the data that is coming from your websites or apps, mobile apps. Now, this data is very different from the transactional data. And usually the volume of such data is also very high. Some of the data may not be stored in your system and they may be in unstructured format. For example, the social media data, the data about on reviews of your products that is stored in, let's say, Facebook or Instagram or Google reviews. That data is not stored in your systems. It is stored in some third-party systems. So they need to be extracted, and this data, for the purpose it is being used, has to be treated as unstructured data, and they have to be treated differently. And very recently, with the advent of Industry 4.0, we have another type of data that is coming in, which is called the machine-generated data. That means we have sensors in the different machines in factories, and these sensors are passing constantly different type of data related to the parameters of the machine, like the temperature, the vibration, and similar other parameters. And these parameters are used to find out the health of the machine. Machine learning models are being used to train on this data and predict whether a machine is going to fail or not. It is not only helping to predict whether a machine will fail or not, it is also helping to control machines from a remote location. These are called digital twins. So this type of data has a wide application in the industry today. And this entire subject is called Industry 4.0, which obviously will not be going in details in this particular course. It's a separate subject matter altogether. But what is important to note over here is that today the data is of different types, and the data is continuously getting generated, like a stream, like a stream of river or waterfall. It is very different from a transactional data, which is accumulated in batches. When you do a sales transaction, then the sale is recorded. But temperature data, sensor data, digital media data, as users are using your app, they're constantly getting generated. Many times, the format of this data is not known beforehand. So this data, because the sheer size, the nature of the data, that means they're coming in as a stream, and because of that many of these data are unstructured, they cannot be directly fed into the environment which is meant for pre-processing. They need to be fed in one singular repository, which can take any type of data, and just we can use that particular repository to dump any type of data that is coming in without any analysis, because it's not possible to analyze the data because it's constantly flowing in, just like a stream of data, a stream of river. So this place where this data can be dumped is called a data lake. So data lake is a repository of all sorts of data. However, while data lake is very efficient as a dumping ground, as a place to have all sorts of data, we cannot use the data in the data lake directly to pre-process, because the data now needs to be given a shape and a form. The schema of the data needs to be defined. And all of this will require some engineering on the data. So that means we need to do some engineering on the data before this data can be fed for pre-processing. This engineering of the data is typically called ELT. ELT stands for extract, load, and transform. So you need to first extract the data from any source, load it on the data lake, and then transform the data in a way that it can be pre-processed. Now, this entire activity is a pretty complicated activity, and it takes a substantial amount of time and resources. And this activity is called data engineering. Where do we do this activity? Now, till very recently, these activities were done on on-prem servers and with specific environments on the server. While many companies still prefer to do it in a server that is on-prem, this has certain problems. Because this entire process of building a data lake and the whole process of extraction, loading, and transformation is a complex process. It requires a lot of resources and expertise to build it bottom up. Plus, the amount of storage and compute that is required to do this processing of ELT can be extremely expensive for organization. So over a period of time, what most organizations have done is to move this entire activity on the cloud. The advantage of moving this in the cloud is similar to the advantage of moving any data on the cloud. That means you have a variable storage and compute facility, which you can expand or contract as per the requirement, and you can pay as you go. So obviously, this is much more advantageous to most organizations. The second most important reason for moving this into the cloud is the fact that most of this process of building a data lake and extraction, loading, and transformation requires a lot of engineering activities which needs to be built bottom up. Most of these cloud platforms are now providing inbuilt components, which are like drag and drop, plug and play. And you can assemble these components to build this entire pipeline of data lake, extraction, loading, and transformation. This makes the job of preparing the data for machine learning models much easier compared to doing it on an on-prem server. These kind of services provided by the cloud service providers are called platform as a service, or PaaS. We have three major cloud service providers that provide this kind of services. Number one is Amazon Web Services, or AWS. Second one is Microsoft Azure. And the third one is Google Cloud. Not necessarily in any order of preference. These are the top three cloud services which are providing the data engineering services as platform as a service. In this particular series of sessions, we are going to use Microsoft Azure to understand some of the activities that can be done in this entire process of building data lake and extraction, loading, and transform. One thing you need to be very clear that extraction, loading, and transform is not the same as extraction, transformation, and loading, or ETL. ETL is a typical activity that is done to convert data from an OLTP system, or online transaction processing system, to an OLAP system, or online analytical processing system. Online transaction processing system is used to record any transaction, a sales transaction, purchase transaction, finance transaction, accounting transaction, etc. However, the online transaction processing system are typically built on normalized relational database management system, which are very good in terms of maintaining the consistency of the data. Typically, it maintains the ACID properties that which is a hallmark of any relational database management system. ACID stands for atomicity, A for atomicity, C for consistency, I for isolation, and D for durability. This ensures that the data that is stored when a transaction is carried out is atomic, consistent, and have the properties of isolation and durability. I'll not get into the details of this process, this characteristic, because you might have already studied this as a part of your relational database management system courses. However, this type of data is not, this type of management of the data is not efficient while querying the data. In querying the data, you require very efficient computing frameworks. So the data should be structured in such a way that the compute requirements are low. It is easy to compute because that's where you are using a lot of queries. Whereas consistency may not be very important there because already your source data is consistent. So any data taken from the source data will also be consistent. So what in industry you need to do is to convert this OLTP system into a format where it is easy to query. However, from a storage perspective, it may not be the most efficient way. So you just store only the relevant portion of the data which you want to query and use this system to query the data. These particular systems are called OLAP system, online analytical processing system. Data warehouses are built on OLAP system. The process of converting a data from the OLTP system to the OLAP system is called the ETL system, extract, transform, and load. You extract the data from the OLTP system, transform the data so that querying becomes easier, and load the data into a data warehouse or OLAP system. So that is a different process. We are not talking of that process here. We are talking about the, the acronym is little similar, but the process is very different. It's called the ELT system, extract, load, and transform. So this is the part of the data engineering. In the next session, we'll briefly talk about the other part of this, this diagram, which is the deployment part. That means what happens from here? Where does the data go from here? Okay, so that's the deployment part, and we'll talk about that. So between the activity that you do before the model, which is on the left-hand side, and the activities you do after the model has been trained, that is on the right-hand side, between these two activities, they actually constitute 80 to 90% of any work in a data science project.